Welcome to the Agrihood. Carnes Crossroads is a new home community with a farm-to-table lifestyle. Just outside of Charleston, here, community is defined by gathering together and our deep connection to nature. Our future farm and amenities are taking root and blooming into something you've always dreamed of in a fun, healthy, and social environment. Come home to the Agrihood, where you can plant roots and thrive.
Learn more at carnescrossroads.com.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime Series 25, Episode 140, for broadcast on the 26th of December, 2022. Coming up on SpaceTime, NASA's Mars InSight lander goes silent, ending its mission on the Red Planet. The biggest Marsquake ever recorded. And the 2022 launch window closes on Southern Launch without a liftoff all year. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Mars InSight lander has failed to respond to calls from mission managers back on Earth and may have gone silent after running out of power. Attempts to re-establish communications with the spacecraft have so far been unsuccessful, and teams at NASA's Jet Propulsion Laboratory in Pasadena, California are now coming to terms with the possibility that the mission is over. InSight has been studying the Martian interior over the past 4 years, but the constant and gradual buildup of dust on its solar arrays has meant a steady and consistent drop in the power available to run its systems. The lander's power has been declining for months now, and mission managers were expecting the mission to come to its end before January. By November, InSight's solar arrays were generating just 20% of the power they were producing when the spacecraft first landed on Mars 4 years ago. NASA reported the loss of contact with InSight just a day after posting what may well turn out to be the last image ever sent by the lander, a spectacular view showing the majestic Martian horizon with the spacecraft's dust-covered seismometer and robotic arm in the foreground. NASA launched InSight aboard an Atlas V 401 rocket from the Vandenberg Space Force Base in California back in May 2018, what was meant to be a 2-year mission to study the Martian interior using a heat probe and seismometer. The Lockheed Martin-built spacecraft successfully landed on Elysium Planitia in November 6 months later. The heat probe, which was supposed to drill a few meters beneath the Martian surface, failed to reach its target depth because of the unusual sandy regolith. But the seismometer was a great success, detecting over 1,300 Marsquakes and providing scientists with a unique insight into the red planet's internal structure. Seismology provides scientists with a picture of what's happening beneath the planet's surface, including its water content, how much crust there is, and how the deep interior is structured. Like on Earth, most detected Marsquakes are thought to occur due to fault movements. As the planet cools, it contracts. But Mars also gets a lot of meteor impacts, and these also send vibrations through the planet like a hammer hitting a bell. Its initial success meant the 684-kilogram lander's mission was ultimately extended another 2 years. Overall, InSight was operational on Mars for 1,440 sols, that is Mars days, the equivalent of 1,480 Earth days. This report from NASA TV.
Touchdown confirmed.
InSight has been fantastically successful. We've gotten more science than we had ever dreamed that we would get during the course of this mission. InSight's primary goal was to better understand how the terrestrial planets, the rocky planets, formed and evolved.
First, we landed an incredibly sensitive seismometer on the surface of Mars, and with that we were able to record over 1,300 Marsquakes.
And these range all the way from tiny little tremblers that just barely go over the noise background to a handful of quakes that were larger than magnitude 4.
And feeling those vibrations, the scientists can actually take that information and use that to reconstruct all the material that those Marsquakes traveled through and thereby see the interior of the planet.
We looked at its core, which is big and not very dense. We looked at its mantle, which is not so hot. And we looked at its crust, which is not too thick and not too dense compared to some of our pre-mission expectations.
By measuring the detailed structure of the inside of Mars, it gives us a snapshot of what the planet looked like 4.5 billion years ago. The other thing that we've been able to do is make a very detailed record of the weather at Mars. So we have a really good weather station, which has allowed meteorologists to study the weather at the InSight landing site and relate that to the climate changes on Mars.
What we didn't do, unfortunately, was make the heat flow measurement we wanted to make. Our heat flow probe was supposed to get 3 to 5 meters down, and we were unable to reach that depth.
But we were able to get some of those measurements, such as the heat transfer amongst the soil.
InSight is a solar-powered mission. We have solar panels, and they were designed to give us enough power to easily get through the first 2 years.
But there's a lot of dust in Mars' atmosphere, and that's falling down on top of our solar arrays and slowly blocking the sun.
As the panels are getting dustier, we started racking our brains with whether there's anything we can do to try to clean off those panels ourselves.
When the idea of using dirt to clean the solar arrays was first proposed, it seemed counterintuitive.
We were actually able to use the arm and the scoop to scoop up some soil from the ground and dump it over the lander, having some of that heavier sand blow onto the arrays and knock some of the dust off. So we essentially used it as an array cleaning tool.
Cleaning with dirt actually worked.
It allowed us to actually keep the instruments going during the low power season where the Mars is farthest from the sun during the winter. Unfortunately, later the power dropping so quickly due to the atmosphere getting dustier, due to the alignment of Mars and the sun.
The last day is bittersweet. That first moment where we don't hear from the lander when we expect to, that's tough.
It's left a permanent mark on me, and I literally tattooed InSight onto my arm. I'll never let it go.
We've really rewritten sort of the chapter of the encyclopedia on the interior of Mars. That was our last big hole in our understanding of the planet.
There's a lot of data that people are going to be looking at for decades to come.
We accomplished so many of our science goals, and we're going to have something to look back on and be proud.
And in that report from NASA TV, we heard from InSight Principal Investigator Bruce Bannert, InSight Project Scientist Mark Panning, InSight Science and Instrument Operations Lead Elizabeth Barrett, and InSight Deputy Project Manager Catherine Zamora-Garcia. This is SpaceTime. Still to come, the biggest Marsquake ever reported, and Southern Launch finishes the year off without a single flight from its Whalers Way Orbital Launch Complex on South Australia's Eyre Peninsula. All that and more still to come on SpaceTime. And continuing with our look at the scientific legacy of NASA's InSight mission, scientists are reporting InSight's detection of the largest Marsquake ever recorded on the Red Planet, some 5 times bigger than any previously recorded event. The quake, led on the night of May 4, 2022, triggered InSight's seismometer with reverberations lasting many hours. The findings, reported in the journal Geophysical Research Letters, indicates that the amount of energy released by this one single event was equivalent to the cumulative energy released by all other Marsquakes seen so far. And although the epicenter was over 2,000 kilometers away, the seismic waves recorded at InSight's location were so large they almost saturated the seismometer. The study's lead author, Taichi Kawamura from the University of Paris, says it was the biggest Marsquake ever seen. The largest previously recorded Marsquake was in August 2021, and it was around a magnitude 4.2. By comparison, the May 2022 quake reached a magnitude 4.7. And remember, just like the open-ended Richter scale readings on Earth, Marsquake readings are logarithmic. The quake was so powerful, it was the first time scientists were able to identify surface waves moving along the crust and upper mantle that had travelled around the planet multiple times. In fact, the waves from this record-breaking quake lasted about 10 hours. Quite a bit, considering previous Marsquakes never exceeded an hour. It was also curious because this time the epicenter was close to but outside the Cerebus Foci region, which is the most seismologically active region on the red planet, and the possible location of a deep mantle plume. Marsquakes are often divided into two types, those with high-frequency waves characterized by rapid but short vibrations, and those of low frequency, where the surface moves only slightly but with a larger amplitude. But this seismic movement was rare because it exhibited characteristics of both high and low frequency quakes. Kawamura says further research might well reveal that previously recorded low and high frequency quakes are merely two aspects of the same thing. As on Earth, studying how seismic waves travel through rocks can give geologists clues about the past forces which helped shape the planet. Scientists combined measurements from two types of surface waves from the May 2022 event called Love and Rayleigh waves in order to infer the speed of underground shear waves, which travel horizontally and move rocks perpendicular to the direction of the wave propagation. It's the first time Love waves have been observed in conjunction with Rayleigh waves on Mars. The measurement showed that the shear waves move faster in the crust when rocks between 10 and 25 kilometers underground oscillate in a direction almost parallel to the planet's surface, compared to rocks which are vibrating in a vertical direction. This wave speed information is related to deformations inside the crust. Alternating volcanic rocks and sedimentary layers, likely deposited long ago or from a very large impact event, most likely account for the seismic wave measurements being observed. Now, these data also enabled scientists to learn that shear waves are moving faster in the Martian southern highlands area than in the northern lowlands. The northern hemisphere of Mars has lower elevation and is covered with more craters than the southern hemisphere. A large asteroid impact in the lowlands has been the prevalent theory to explain the origins of this difference. And the new data does point to the presence of thick accumulations of sedimentary rocks, as well as a relatively higher porosity in the lowlands. Large amounts of gas, such as trapped air in these sedimentary rocks, tend to slow the waves down. And that's more evidence supporting the idea of a giant lowlands impact. This is SpaceTime. Still to come, we look at more stunning meteoroid impacts detected by InSight on the red planet Mars, and despite several attempts, Southern Launch is yet to fly a rocket from its Whalers Way launch site. All that and more still to come on SpaceTime.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
In this episode of Space Time, we've been looking at the scientific legacy coming through in the data from NASA's Mars InSight mission, which has just reached its final conclusion. Scientists sifting through this data have detected more meteor impacts on the red planet's surface, which in turn provide more data about the Martian interior. And we know these were meteor impacts because they weren't just felt by the InSight lander seismometer, the craters they created were seen by the Mars Reconnaissance Orbiter in space. InSight recorded a magnitude 4 Marsquake on December the 24th last year, but scientists were only able to determine the cause of the quake later, after spotting a big new impact crater from space on February 11th this year. The meteoroid strike is estimated to be one of the biggest seen on Mars since NASA began exploring the red planet. The collision excavated massive boulder-sized chunks of ice which had been buried close to the Martian equator. And that discovery alone has amazing implications for NASA's future plans to send astronauts to the Red Planet. After all, buried ice means water. Scientists determined the quake resulted in a meteoroid impact when they looked at before and after images from NASA's Mars Reconnaissance Orbiter and spotted a yawning new crater. Offering a rare opportunity to see how a large impact shook the ground on Mars, the event and its effects have been detailed in 2 papers in the journal Science. The meteoroid is estimated to have been between 2 and 5 meters in size, small enough to have been burnt up in the Earth's atmosphere, but not in the thin Martian atmosphere, which has just 1% of the density of Earth's. The impact, in a region known as Amazonia's Planitia, blasted a crater roughly 150 meters across and 21 meters deep. Some of the ejecta from the impact was thrown as much as 37 kilometers away. With images and seismic data documenting this event, it's believed to be one of the largest craters ever witnessed forming anywhere in the solar system. Now, there are many larger craters on the Red Planet, but they're all significantly older, therefore predate missions to Mars. Before it shut down, InSight was examining the Martian crust, mantle and core. And seismic waves were key to the mission being able to achieve this. Since landing back in November 2018, InSight's detected over 1,300 Marsquakes, including several caused by small meteoroid impacts. But the quake resulting from the December 2021 impact was the first observed to have surface waves, a kind of seismic waves which ripple along the top of a planet's crust. The second of the 2 science papers related to this big impact describes how scientists use these waves to study the structure of the Martian crust. The impact's blast zone was clearly visible in the Mars Reconnaissance Orbiter data, thereby allowing scientists to pin down the 24-hour period in which the impact occurred. These observations correlate with the seismic epicenter, conclusively demonstrating that a meteoroid impact did cause the large December 24 Marsquake. The massive crater, exposed ice, and a dramatic blast zone, all preserved in the Martian dust. Establishing the rate at which craters appear on Mars is critical for understanding and refining the planet's geological timeline. On older surfaces such as those found on Mars and the Earth's moon, there are more craters than on Earth. That's because our planet goes through a continuous process of erosion and plate tectonics. Collectively, these erase older features from Earth's surface. New craters also expose materials from below the surface. And in this case, large chunks of ice scattered by the impact were viewed by the Mars Reconnaissance Orbiter's cameras. The subsurface ice will be a vital resource for astronauts who can use it for a variety of needs, including drinking water, agriculture, and even rocket propellant. The other interesting thing is that buried ice has never been spotted this close to the Martian equator before, so it's an interesting find considering the equator is the warmest part of Mars, and that makes it an appealing location for astronauts to land. One of the study's authors, Associate Professor Katarina Miljkovic from Curtin University, says the detection of a large crater associated with the Marsquake marks an important point in Martian geologic history.
We had a very, very fortunate large impact event happening on Christmas Eve last year, and it's a 150-meter crater in diameter. So it's made by about 5-meter in diameter rock, or if you will, about 200 tons in mass, that struck Mars on Christmas Day, Christmas Eve, Christmas Day, and we've got a magnitude 4 Marsquake out of it recorded, and also it was followed up with kind of somewhat independently at the same time with MRO, with Mars Reconnaissance Orbiter, that provided us with a beautiful photo as well of that crater. So we never really knew how many impacts we're going to get during the lifetime of InSight mission. You know, a number could have been anything between 0 and 30, but we were hoping for at least a dozen a year, and then we've got a handful a year. And we didn't really expect that we get one that is quite large as that. But so I guess Cosmos gave us a little treat. So it definitely is one of the major quakes that InSight has recorded since we started operating in late 2018. The really cool thing about this crater is that it actually excavated subsurface ice, and that ice is anywhere in the depths of a few meters to up to about 10 meters depth. And even cooler than that is that this crater is at 35 degrees northern latitude on Mars, which is kind of the southernmost point in terms of that location for ice. So generally ice is located in mid to polar latitudes, but at 35 degrees latitude it's kind of quite close to the equator to be excavating ice, but it did excavate ice from some depth. So that really gives us another dimension as to mapping ice in subsurface of Mars, as well as having quite a distinct quake that helps us further identify the structure of the interior of Mars.
This puts us very close to the area where humans are likely to be located when they go to Mars, doesn't it?
Yeah, no, absolutely. So we do like equatorial regions because it's safer to land there and it's easier to communicate when you're in equatorial regions. So if you're thinking about human base being located somewhere on the planet, then probably it's safer to put it in the region that was well explored and that the communication is easier, and also that it's warmer during the day. So having more detailed mapping of where subsurface ice might be then could be providing us with a better source of local resources for supporting those humans on the planet. So definitely helps in our mapping efforts for underground ice on Mars. I mean, we knew that there is ice in subsurface of Mars. That is not news. What was new is that it was identified at deeper depth, at lower latitude. So certainly it can be of assistance, but it doesn't mean that we've got ice anywhere on these latitudes. That region may as well be patchy, and we might be lucky that in some regions there is underground ice and in some regions there aren't. So I think we are a bit far from taking this information for granted in the sense that, it hasn't been confirmed that it's global distribution of ice in these regions. It just says that in one of the regions it can exist in kind of like southern regions as well.
The earlier evidence was simply what the Mars Phoenix rover had found at its location, but it was much higher latitudes where it was expected to be cold. So with Phoenix scratching the surface and finding ice there, that was expected, but to have this new ice found where it was, the only other indications really are those strange little rivulets we see on the sides of cliffs, those recurring slope lineae, which we're still not sure what they are. Some say they're dust. Others say, no, that looks like melted water. But it's all a very tantalizing mystery, isn't it?
It is, very much. So there are transient events on Mars that look like some fluvial-like activities. So those recurring slope linear RSLs on Mars, they happen in like steep slopes, like in craters and some certain regions where the surface goes through temperature changes on a daily basis or seasonal changes, where possibly it goes warm enough such that it starts loosening up any bound fluid so that it can then let that debris flow go down with gravity. So that doesn't really suggest that there is free-flowing water. It may, but it probably is a little bit more complicated than that. So it's probably some debris flow that gets loosened by those seasonal or daily temperature changes that then promotes that the formation of those linear features.
Can I ask you about the Marsquake itself? That occurred on Christmas Eve, and then it was a couple of months later when you've got confirmation from the Mars Reconnaissance Orbiter that this was, in fact, the result of an impact. How could you marry those two together?
Because it's such a massive quake, it was identified more as a near-surface source, which is typical for impacts, which is why it was suspected as an impact. Also, the Marsquake service is pretty good at determining azimuth, so they can also say which direction the wave had come from and how far. And given it being a near-surface event, then they could suspect that you can advise an orbiter, say, go have a look at that place. So it was a mission collaboration effort, to say.
Mars has just gone through not a full global dust storm, but certainly a large regional one, and this may well have been fatal for the InSight mission. There was already dust on the solar panels, and now there's more dust on the solar panels, and InSight's life may be measured in days rather than weeks at this point in time.
Look, InSight has ticked all the boxes that it was designed to do. So it went through prime mission and extended mission, and it basically satisfied all the objectives that it set out to do. And we've got more than 1,000 quake recorded, and of those, some of are really high magnitude, so they provide a high level confidence in mapping the interior, deeper interior particularly. So in a sense, if InSight lived longer than this period of time, would we get more new science, or whether we've satisfied our curiosity for the time being? So the way the InSight was designed is that it's a lander with solar panels on. So we, the NASA engineers knew that eventually dust will settle on the panels, and that will that will limit the lifetime of the mission. And that was basically planned for. So it's not that the dust storm happened all out of the blue and it made mission no longer feasible. It's just that we know that dust settles on solar panels on all the kit that we have on Mars, and that has to be accounted for. So I think having lasted this long is still quite a treat. So having to have to say goodbye to InSight it's not premature. It's the way that it was designed as a mission lifetime. So dust storms happen from time to time. They can help clean your solar panels, or they'll sell more dust on it. So, those are the things that you can't really predict as much. But the position of dust in the solar panels is something that is expected to happen and eventually will lead to the end of the mission. So we were just lucky enough to get a good set of data in the time that we had.
The data coming from InSight, what has that actually told us about the internal structure of the red planet?
There are a few things that we've learned about Mars from InSight that we didn't know before because we didn't have the capacity. The analysis of seismic activity has shown us that the core of Mars is slightly larger than previously thought and predominantly made of liquid based on the seismic velocities. That lithosphere, the present day of Mars, is quite thick and probably thicker than thought before. That means that mantle is somewhat homogeneous and that the crust is made out of 2 to 3 layers, and it's quite variable in structure and the thickness as well. So it is kind of expected, the crustal structure, but it's good to get that kind of layering in the crust and the changes with structure and the kind of thickness and the densities. So those are the really fundamental understandings of the innards of Mars that we can now safely say.
I guess the hints for the thickness of the crust comes from the lack of tectonic activity that we see on the surface. There's no evidence of plate tectonics there. And the liquid in the core must have come as a bit of a shock. A lot of people had speculated that the core of Mars had already solidified because of the lack of a magnetic field.
Well, there should have been or could have been ancient magnetic field on Mars that at one point got switched off and we don't know how or why. So that's still stuff that is very much an open science question. And not having tectonic plates on Mars doesn't come as a surprise because of the surface geology suggesting that. So the way the variability in the crustal thickness of Mars may come from the way that Mars has evolved thermally as a planet, or it could have come from a different source. But certainly there is no evidence of multiple plate tectonics on Mars.
That's Associate Professor Katerina Milichkovic from Curtin University, and we spoke with her just hours before the InSight lander went silent. And this is SpaceTime. Still to come, Southern Launch ends the year without any flights from its Whalers Way space complex. And later in the science report, a new study warns that extinction cascades caused by human activity will wipe out more than a quarter of the world's biodiversity by the turn of the century. All that and more still to come on SpaceTime. The launch window has now formally closed for the year on Southern Launch's attempts to send a rocket into the skies above its Whalers Way launch complex on South Australia's Eyre Peninsula. 2 test rocket flights were planned, but both experienced leaks on the launch pad. The missions, numbered VS02 and 03, would each have used a 10-metre tall AT Space Kestrel 1 two-stage sounding rocket. AT Space was founded in Australia in January 2021 as a sister company to Taiwan's Thai Space. Both missions were carrying Innova technology spacecraft, which are designed to provide turnkey delivery services for payloads. Both flights were designed to test the new launch vehicles and to gather data on noise and environmental impacts on conducting orbital launches from the Whalers Way complex in anticipation of future commercial launches from the facility, which will see up to 40 flights per year. The VS-02 mission was called off at T-minus 57 minutes after the nitrous oxide oxidizer began leaking while it was being loaded on the rocket's first stage prior to liftoff. Further investigations revealed the leak would require greater attention than available at the launch complex, forcing mission managers to transport the rocket back to the AT manufacturing facility in Adelaide. It was the second scrub for the VS-02 mission, following an earlier launch cancellation back in November after unprecedented lightning strikes at the launch facility struck the rocket. Following the latest scrub for the VS-02 flight, it was decided to instead go ahead with the launch of the VS-03 mission 3 days later. But that wound up also being scrubbed following another oxidizer leak. This time it was in the second stage, detected about 15 minutes before launch. And again, the lack of proper facilities at Whalers Way means repairs will need to be carried out at AT Space's manufacturing facility in Adelaide. The VS-03 mission would have sent 3 payloads into space. Both missions will now be rescheduled for sometime next year. Southern Launch's first attempt to send a rocket into space from Whalers Way back in 2021 also ended in failure, with the launch vehicle catching fire on the pad, suffering extensive damage. Still, as Southern Launch are finding out, and which every other space organisation already knows, space is hard, and it's only by repeated efforts that you finally get to join that exclusive club. In September, Southern Launch formed a sharing partnership with the United States Space Command, the first commercial Australian space company to enter such an agreement. Under the agreement, Southern Launch collaborates with the US Space Command to ensure its rockets follow a safe trajectory into space. When the O2 and O3 missions do finally fly next year, they'll allow the company to test new technologies under launch conditions, monitor different payloads to help develop future missions, and test different communications protocols. The flights will also provide valuable data for the Kestrel 5 orbital rocket now under development. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. There are growing warnings today that extinction cascades caused by human land use and climate change will wipe out more than a quarter of the world's biodiversity. A report in the journal Science Advances shows that interconnected species loss through cascading extinctions are unavoidable, and that the Earth will lose some 10% of its animal and plant species by 2050, rising to 27% by the turn of the century. The study's authors from Flinders University and the University of Helsinki used one of Europe's most powerful supercomputers, together with new modelling techniques, to create hundreds of synthetic Earths, complete with virtual species and more than 15,000 food webs each. The model allowed scientists to predict the interconnected fate of species that will likely disappear from the ravages of climate and land use changes. The complexity of this new tool is quite amazing. Each virtual Earth is populated by more than 33,000 vertebrate species, organised into 15,000 different food webs distributed across the planet. The scientists then simulated future climate and land use changes, and they observed the response on vertebrate communities at monthly intervals from 2020 through to 2100. And those simulations predict a dramatic end-of-century loss of diversity. By 2100, on average, as much as 27% of vertebrate species could disappear from local ecosystems. And in the worst-case scenarios, the extinction of just a few key species wound up collapsing entire communities in a chain reaction event that amplified the effect of biodiversity loss by up to a staggering 184%. Bit of good news now, and engineers have used sound waves to boost production of green hydrogen by 14 times. The findings, reported in the journal Advanced Energy Materials, offers a promising new way to tap into a plentiful supply of cheap hydrogen fuel for transportation and other sectors, which could radically reduce carbon emissions and help fight climate change. It works by using high-frequency sound wave vibrations during electrolysis, releasing 14 times more hydrogen than standard electrolysis techniques. Electrolysis involves electricity running through water with two electrodes to split the water molecules into oxygen and hydrogen gases, which appear as bubbles. This process produces green hydrogen. Green hydrogen represents just a small fraction of hydrogen production globally because of the high energy requirement involved. Most hydrogen is produced by splitting natural gas known as blue hydrogen, which emits greenhouse gases into the atmosphere. The authors say using sound waves also eliminated the need to use corrosive electrolytes and expensive electrodes such as platinum and indium, and instead allowing them to use cheaper silver. The sound waves also prevented the buildup of hydrogen and oxygen bubbles on the electrodes, which greatly improved both conductivity and stability. A new study suggests that humans' knowledge of how to make and use pottery goes back almost 8,000 years. And the new findings also suggest that this technology was most likely shared between hunter-gatherer communities in Europe through cultural and social traditions before the spread of agriculture. The findings, reported in the journal Nature, indicate that the technology to produce plates and bowls must have spread much faster than previously thought. Scientists reached their conclusions by analysing various aspects of 1,226 pottery remains from 156 hunter-gatherer sites in Eastern Europe and Russia, including radiocarbon dating, shape and decoration. The analysis suggests that pottery was spread through cultural transmission and social traditions, and was inherited by successive generations of hunter-gatherers around 5,900 BCE. Hunter-gatherer societies lived on the European continent early in the Holocene period, around 12,000 years ago, and relied on hunting, foraging and fishing for subsistence, leaving a relatively sparse archaeological record compared to early farming societies. A new survey has found that some 67% of Americans believe they've had a genuine paranormal experience. The YouGov poll also showed that 19% of people truly believe they've actually seen a ghost or spirit. Only 29% of those surveyed believe there was a scientific explanation for their experience. Tim Mendham from Australian Skeptics says it's amazing how many people will just assume their experience must have been supernatural.
People who do the analysis of these surveys tend to be a bit on the woo side of things. They tend to be a bit of believers, but basically it's 60% of Americans, as you said, believe they've had some sort of paranormal experiences. 37% have a presence of unknown energy, which is a bit vague. 33% have a unexplained sound or music. 30% have felt or smelt an unexplained odour. 29 hearing voices.
I usually blame the dog.
Yeah, the odour, yeah. And the interesting thing, though, is that people have these vague feelings, and everyone can have vague feelings, like you see a movement out the corner of your eye, or something smells funny, or as you say, the dog, or you hear something which is like a house creaking or something like that. It's been very common, actually, when people are in lockdown with pandemics, they suddenly get to hear all the sounds their house makes. But 35% of the survey said there's likely to be an otherworldly or supernatural explanation. 29% think there is a scientific explanation that they just don't know what it is. In other words, creaking house syndrome. And 36 aren't sure about the cause. So 67% of people reckon they've had a paranormal experience, but only 35% think it's actually something supernatural. And so you try and equate those two, and basically a lot of people have felt something, but they know it's nothing there. In other words, or they're not sure. Of those people who reckon they've seen a ghost or a spirit, 29% said the identity of the spirit or ghost was someone they knew, like a family member. 28% they say was someone they didn't know. 28% also said they believe they've seen both types, someone they know and someone they didn't know. What a ghost is doing, is the ghost trying to approach or reach particular people, like family members, or is it just random? And there is so much random actually in the statistics that it's not that useful to actually to look at. But still, surveys are surveys, and people will continue to do them, trying to figure out the meaning of the results.
So, was the ghost wearing clothes?
This is always the issue, isn't it? Apparently, ghosts carry their clothes with them, so they have ghost clothes. And I was trying to figure out, is the ghost in the form that it was when it died? If it was hideously scarred in a car accident, burned or whatever.
Yeah, like in
Beetlejuice. It was the boat. Also, American Werewolf in London has a good one where the ghost looks horrible because it's all torn up by a werewolf, and it gets gradually worse as he starts rotting. And then you have the alternative, which is Titanic, where the ghost comes back as a young woman rather than the old woman she was when she died. You figure that one out.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.